This is lesson 6.1, Exploring Counting Problems. We're going to be looking at how many possible outcomes there are for different compound events. There's 4 techniques that you can use if you're looking for the number of outcomes, and the first one is listing. If I say how many outcomes are possible when you flip a coin twice, you can list the possible outcomes. Heads and then heads, heads and then tails, tails and then heads, tails and then tails. That's just called listing. Another method we can use is what's called a tree diagram. The tree diagram helps you organize that information that you, instead of listing where you're just kind of going on your own, tree diagram's a little bit more organized, but it's not very good when there are lots of different ways. The third way is to use what's called the counting principle. And the counting principle is great when there are lots of different possible outcomes, when it's going to be too much for a tree diagram. And then another method is to make a chart or a table. And those are the 4 ways that we're going to be looking at today. So let's explore this. The first one we're going to look at is the listing technique. Chloe, Stacy, and Emma want to go to the movies. What are all the different ways they could sit together? So we know that there are going to be 3 seats for them to take up, and the first person to sit down could be Chloe, and then Stacy could sit next to her with Emma on the other side. But another option is for Chloe to sit down first and Emma to sit down next to her, and then Stacy to sit down last. Those are all the different ways that Chloe could sit down first. What if Stacy sits down first? Then you could have Stacy followed by Chloe and then Emma, or it could be that Emma wants to sit in the middle, so it could be Stacy, Emma, Chloe. And then we have the possibility of Emma sitting down first. So Emma could sit down first, followed by Chloe in the middle and then Stacy on the other end, or it could be Emma and then Stacy and then Chloe. So these are all of the different ways the girls can sit together at the movies, and we can see that there are 6 different ways. Okay, now let's look at tree diagrams. Diagrams. Jackie flips a coin 3 times. What are all the possible outcomes? Well, it's important with tree diagrams that you think about what the outcomes are possible each time. For example, when she flips the coin the first time, what are the possible outcomes? Well, she could get heads or tails. So we're going to write down she could get heads first or tails first. Then on the second time she flips it, what are the possible outcomes? Well, she could get heads or tails the second time. So if she gets heads the first time, she could also get heads the second time, or she could get heads the first time followed by tails the second time. If she got tails first, she could get heads second. If she got tails first, she could get tails second. So now we've talked about 2 different flips of the coin. You see each column is kind of representing a flip. Now on the third flip, our outcomes are still heads or tails. So she could get heads first, heads second, and heads third, or she could get heads first, heads second, tails third. She could get heads, tails, heads, or heads, tails, 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 heads, heads, or tails, head, tails. She could get tails first, tails second, and heads third, or tails first, tails second, and tails third. This right here, this diagram represents all the flips. When we do a tree diagram, though, we always want to make a list of what happened. So this track right here says heads, heads, heads. She could get heads all 3 times. Or she could get heads, heads, tails. You don't need to draw the loops. I'm just trying to help you follow me. She could get heads, tails, heads. That's getting kind of ugly, so I'm going to stop drawing that. Heads, tails, tails. Those are the 4 possible outcomes of getting heads first. If she gets tails first, she could get tails, heads, heads. Or she could get tails, heads, tails. She could get tails, tails, heads. Or tails, tails, tails. There are 8 possible outcomes for flipping a coin 3 times. The nice thing about these diagrams is then if I say what's the probability of getting heads exactly once, we can look at our diagram and find how many times there are to get how many ways there are to get heads exactly once. There's this way and this way and this way, so 3 out of the 8. So if I asked you what's the probability of getting heads exactly once, we would say 3/8. Now right now we're not jumping into probability just yet, but that's what this is preparing us for. Okay, this one says, a mother has 4 children. What are all the possibilities for a boy-girl order? This is one that's also good for drawing a tree diagram. We have that first child, and that first child could be a boy or a girl. Then the second child could also be a boy or a girl. So you could have boy-boy or boy-girl. You could have girl-boy or girl-girl. Then we go into the third child. We could have boy-boy, boy, or boy-boy, girl, boy-girl, boy, boy-girl, boy, girl-boy, boy, girl-boy, girl, girl-girl, boy, girl-girl, girl. And then, so that represents 3 of the children. And then the last one could also be boy or girl. So boy, 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 boy or girl, boy, girl. And you notice that the more times we do this, the messier it gets. So this is why tree diagrams aren't real great when you have a whole lot of outcomes. But they are nice to organize that information. And then we would make a list of all of those possibilities, starting with boy, 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 girl, oops, G. And if you count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, there are 16 ways. Now we're going to look at a tree diagram going back to the Chloe, Stacy, and Emma at the movies. This diagram is going to look a little bit different. The first person to sit down could either be Chloe or Stacy or Emma. So for the first seat, we say Chloe, Stacy, Emma. Then we need to look at the second seat. Well, if Chloe sat down first, the only possibilities for the second seat are Stacy or Emma. If Stacy sits down first, then your only choices are Chloe or Emma. And if Emma sits down first, your choices are Chloe or Stacy. And then once the first 2 have sat down, there's no choice for who sits third. If it's Chloe and then Stacy, Emma has to sit next. If it's Chloe and then Emma, Stacy has to sit next. This would have to be Emma, Chloe, Stacy, and then Emma, Stacy, Chloe. And so sometimes your tree diagrams, each branch is going to look a little different. What's important is the only thing you put in the tree diagram are the possible outcomes. So here you only see the girls. You don't see first chair, second chair, third chair. If we go back here, you don't see first child, second child, third child, fourth child. You only see boys and girls because those are the only outcomes possible. If you want to think about where that other is, this represents your first child. That represented the second one, the third one, and the fourth one. But we don't ever put first child, second child, third child because 1, 2, and 3 are not outcomes for your kids. Okay, now we're going to talk about the chart. Sometimes we call it a table. Either one of those is fine. This example says a pair of dice is thrown. This is the one time I think a table is really good because there are quite a few outcomes here. When you throw a die, you can get a 1, 2, 3, 4, 5, or 6. So what I do for this one is I let this row across the top represent my first throw. I could get a 1, 2, a 3, a 4, a 5, or a 6 on the first throw, and I could get a 1, 2, 3, 4, 5, or 6 on the second throw. Then in the table are all the possible outcomes. I could get a 1 followed by a 1. I could get a 1 followed by a 2. I could get a 1 and then a 3, a 1 and then a 4, a 1 and then a 5, a 1 and then a 6. If I roll a 2 first, I could do 2, 1, 2, 2, 2, 3, and so on. This column is going to represent having a 3 first. 4 first, and so on. And then you see when we complete the table, there are 36 possible outcomes when you roll a die twice. And then if I want to know what's the probability of getting doubles, I can see it right there on my table. It's really helpful. The last one we're going to talk about is the counting principle. The counting principle is good when you don't know, when there's going to be a lot of possible outcomes. And you don't really care what they are, you just want to know how many there are. That's when the counting principle is going to become really handy. What you want to think about is how many choices you're going to have to make, or the question might be, how many times are you going to flip the coin? How many times are you going to roll the die? You need to know how many times something is happening. So for this, we have a sandwich place that's boasting all the different sandwich possibilities they offer. You have your choice of 6 different breads. That's one choice you're going to have to make. 12 different types of meats. You're going to need to choose a meat. And 5 different types of cheeses. So you're going to need to choose a cheese. What we do is we say, how many ways are there to choose bread? 6. How many meat choices do we have? 12. And how many cheese choices? 5. And to find out how many possible outcomes there are, we multiply. 6 times 12 times 5, and we get 360 possible outcomes. I want to show you how this works with the other examples we were just talking about really quickly. Here we have a pair of dice is thrown. So you roll the first die, and then you roll the second die. 2 things are happening. There are 6 possible outcomes the first time, and 6 possible outcomes the second time. So if we do 6 times 6, we get that there are 36 possible outcomes, which is what we found with our table. Here we had Chloe, Stacy, Emma. We needed to choose who sat in the first chair, the second chair, and the third chair. Well, how many choices did we have for who sits down first? We had 3 choices. Now, once that person sat down, then there were only 2 choices for the next chair. So 2 choices for chair 1. And once someone sat down there, there was only 1 choice for the last chair. So 3 times 2 times 1 gave us 6 possible seating arrangements. Here with the 4 children, we had 4 things happening. The first child, the second, the third, and the fourth. There were 2 possible outcomes for the first child, boy or girl, 2 for the second, boy or girl, 2 for the third, and 2 for the fourth. So 2 times 2 times 2 times 2 is 16 possible outcomes. So this works for all of the different ways, all of these different things that we've talked about. But sometimes you want to be able to see the outcomes, like you see in the tree diagram, and sometimes you only want the number, and that's called the counting principle. And that's the end of this lesson.